hopefully clear things up a little bit. It's gonna make a video. I recorded a bunch of clips, but I just didn't feel like going through the editing process and everything, so figured screw it, let's do it live. Oop, how do we get this back to 101? Wait just a few seconds, make sure it's all working. Alright, we'll make sure it works up here. I have to mute that. Alright. We're live. Okay, anyway. So here's my controller I've been working on. And I kind of mounted it all here on this little piece of plexiboard just to kind of have it all together. And I just have it tested up just for testing out. Hey TNZ, what's up? Got somebody already joined in. Just doing live stream instead of editing clips. So however it comes out, I guess. So anyway, let's get to the point. And people are starting to chime in. Let's go to the outdoor unit. It's kind of a sad day, but it's not all for loss. That's the point of this stream. So looking at the comments there, I thought about going out on my own. I just don't know if I like the headaches, you know. There is something nice about there being a disconnect between you and customers and stuff like that. Same reason I didn't really want to be a service manager either, which is like you're the one person right before you're like between your man and your owner. I mean, I could do it, but I'd like to be more like a teacher and or just, you know, help people and stuff and not have the political part so much, so or as little as possible. So anyway, so let's get to the point of this. This was the Frankenstein I was working on, right? You guys know about this unit's been up for a couple years for heating my water, and it heated the water perfectly. So I took the compressor out of that and put it in here. Had this hooked up and cooling my Frankenstein laboratory throughout the summer. That worked perfectly. And I bought like a little window shaker thing or whatever, and just for the compressor for $50, you know, and took this compressor out, which is a couple thousand BTUs less, and I had put it in here for the summer. It took a little longer to heat, but it was heating. But then once summer was ending, I'm like, all right, the goal is this is a hybrid, and I want the one compressor to be able to alternatively either cool that room during the summer or heat the water with the heat exchanger, or both at the same time, depending on whichever demands there was, which is the controller inside, which I was building that to do. But I did notice that ever since I pulled that compressor back out and stuck it in here, or actually that compressor was out in there, but ever since I took off that's right, I took this off and plumbed the hot gas, right? I had the hot gas coming out these little nice ports I added to the back here, right? Extra valves, hot gas from the compressor. This compressor went up the wall with insulated pipes over to the heat exchanger right here, and then back down. And then I added the bottom two circuits are condenser. The top two circuits have been evaporator, or for running a heat pump, you know, mode, and you know, to heat the water. And so I got the expansion valve for these two circuits, expansion valve to go to the liquid line, you know, indoor circuit for the high wall. But I noticed it took a little longer to heat and whatever when I first, you know, interconnected that, and I wasn't really needing to cool in that room. So I'm like, I'm just going to hook it up so it's ready for my controller. And I've been working on that controller for like the last month. Well, as soon as it started getting cool, this thing was just freezing up relentlessly. Like, and since I'm live, I can't show you, but there's some, you know, go in there and bring some pictures up. But basically, this would freeze up very even. It was real efficient as cooling goes, but it just wasn't heating the water in a timely fashion. It was just running forever, especially when the water was cold and it started out cold. It just take forever to get the heat going. And I think I just came to the conclusion like 2 days ago, Christmas Eve, I think, while we were doing stuff, I just got thinking about it. I'm like, it's just too small of a compressor for heating the water. And, the water temperatures are kind of elevated, for what you think of what you're going to heat. So 105 degrees, he's like, oh, do you need hotter than that? So I think with just the small compressor, with the additional lines, the additional of the circuit of the condenser, it just wasn't efficient to create heat into that heat exchanger and heat the water. It would cool the room like a mother. It would refrigerate the outside air really well, frost up the coil, because it ran so long, enough humidity in the air, especially in the mornings. So I've had to defrost thing a bunch of times last week, and I'm just like, you know what, without changing a compressor, it just isn't going to work. And let me back up. During this last week, I kind of looked to see what my options were for compressors, and I thought it'd be nice to get a 3-phase scroll, because I have VFDs. And I looked up the smallest one I can find really is a 2-ton, and I only would use that capacity when I needed to speed it up for heat, but other than that, it would just be backed way down. And with the smaller circuits, I don't think it would have any issue with oil return, because it's all about velocity. Like if you turn down like a scroll that's matched for a circuit, you turn down too much, the velocities, with the pipes and everything, it just doesn't bring back the oil. But I think a compressor is technically oversized. I think if I ran it down pretty low for cooling, I don't think it would have had any issues, but you never know. It'd be a gamble to try it, because it's just it's a total freaking abomination, total just like experiment. So I just got thinking that ain't worth it. Now, compressor's like $500 and you have to order it. Dog, get in here. Dobby. I left the gate. Get in the yard, stupid dog. The latest mutt. He seems pretty good though. I'm just rambling right now, but that's the reason I couldn't even make a video on this. I tried to make some clips and I just kept rambling, so I figured I'd go live and then stop and check the comments every once in a while. So anyway, the other day what I did was I kind of added a box with a contactor inside. I should just show you guys, just because my wife would go, hey, there's no hot water, and it would be frozen up when we needed the water. First person would take a shower in the morning, and then the hot water's gone, and the thing would freeze up and really not make any heat. So so a couple days ago, just really quickly, I just took this box. I already had this box, and just threw it. It's just a contactor transformer. That's all it is. And so that's just interrupting the power for the factory strip heat in here, which was just off at the breaker, and then I put on like this timer module here, and I was able to program this Wi-Fi thing just to I was turning off the heat pump in the early morning and just turning that on to make sure it heats. See, this thing is heating right now off that heater out there. We're gonna go see what the temperature is. And it was running down my batteries, not even getting a good charge every day. It's just been running so much. So I'll take this out there and clamp it on the hot gas line, because it's probably hot as hell. I bet you it's at least 170 right now. And that's the whole thing. That thing was, luckily, it would start out just crappy, and then eventually get to like maybe 150. And it was just taking too long to heat the water. So I think, with my trial and error, and just, I don't know, I just didn't realize that this thing was gonna suck as a heat pump as far as in heating mode, heating the water. It refrigerated fine, and that's usually the mindset you have when you're making something with expansion valves and all that stuff. Let's see if I have a good spot to clamp this on. You can see it's like 70 something. Yeah, I got a lot of glare in there, but it's like high 60s out right now. So of course we got really hot weather right now. Damn, that's a lot of glare. I'll let that sit on it for a second while I continue talking. So yesterday, just all in one day, I just came out here and just gutted that thing real quick, took the compressor out, put the compressor back in this thing, and this is pretty much back the way it was. Oops. And I just threw this on. I need to make a doghouse for this. That's nice. Box it all in. Now that's going to be staying on here. I just put this on there because it just keeps the rain off of it. And this thing kicks ass for heating the water. It's weird because look at the surface area. It's 2 rows. This was a condenser coil, turned into evaporator coil. And then I have the top 2 circuits of this, 2 rows, more of it, you know, thinking that it should be great, you know, a little more surface area. It won't run as cold, but what happened was it wound up running way longer. And when we would get down in the low 30s out here, it was just freezing up and staying frozen. So Tom says he's got the notifications while he's performing the same functions, working on his own home personal heat pump, crawling in the attic. That's right, you watched this video, the stream, while you're up in that attic. At least it's not summertime. And my friend's like, what's up with that? So I'm telling him, I go, well, it's just, you know, we're not, your mindset, you know, is like, you know, there's no problem. I've had condensed liquid, feed in the expansion valves. I had a thermistor here, and then one on the suction line, you know, disconnect right now. One inside, it was able to adjust the evaporator superheat perfectly, and that all ran perfect. It's just oversight of how it was going to perform for heating. And it's just funny because it's just the same compressor. Just put it down in there, and just because I added air, you know, direct air heat exchanger after the water heat exchanger, thinking, hey, that's going to bring the head pressure down just a little bit, be more efficient, especially when I'm running it in AC only in the summer and the pump is off. It has to have that coil. It was just in my mind that it should work, but it didn't. I think it just inefficiently was able to compress and build the temperature when it was mild weather out here. So it isn't going to work like I want. Only way it was going to work is if, I think I realize now, is if I had a compressor with more capacity when it was running in heat pump mode to heat the water in mild cold weather. So kind of disappointing. But I think what I'm going to do is I'm just going to add some control on this. Since I have that box in there, I'm going to add a sensor and little basic controller just for the thermistor and the suction line probably, or something, and basically add a defrost. Maybe I might just come out, I might pull the charge and actually plumb it. I don't know, I'll have to see if I get to it. I might put in a hot gas, or I might just turn it off and then turn on the heat strip just when it's it actually freezes up, which has only been a few times each winter. And it defrosts itself when you turn it off. You know, it doesn't take too long. So probably have to put a probe in the coil if I'm going to just do an air defrost, or it just shuts off. And then might have to separate the outdoor fan from the compressor, so maybe so I can keep the fan running and stop the compressor with a contactor and everything. Just have a little controller for that. That way that thing's just kept simple. It's just a heat pump for the water heater. And in the summer, or say in the winter, we'll definitely keep it on the solar charger inverter and try to make it run off the sun as much as possible. In the winters, when this needs to run the most though, 50 degree supply water instead of 80, you know, coming in. And then for now, I'm just gonna take that other compressor, put it in here and get it back working just to be a AC only, because it works. And then later on, I'll probably maybe before summer, I'll just buy one of those cheap mini splits, a small one, like a half a ton or something, or as small as I could get one, 3/4 ton, 115 volt, because that's all that room needs. And have just a separate AC. And I think being an inverter one, I don't think my solar charger inverter will have too much of a fit. But in the summer, when I had that one compressor in here and the smaller one up there, when one was running and it started the other one, it would sometimes trip my inverter. It would switch over to utility, and then after so many seconds it would switch back. They'd both be running, and then it would be able to handle it. But it just didn't like starting a second compressor. And these little rotaries, man, they do pull a pretty good surge when they start. So one at a time is okay, but when one's running and it starts the second one, it just seemed to like, kind of tax that solar charger inverter. So anyway, this looks bad right now, but I'm gonna clean it up. I might go ahead, and since I've been you know, making new controllers, I'm probably gonna redo this, but I'm just gonna probably just have it be AC only, and then eventually I'll just probably cannibalize it. I don't know if I put in a inverter driven mini split. My end goal eventually is to be able to make my own brushless DC controller to run these inverter compressors. But if you look at these compressors, they're all DC. They're actually DC. This is the one from the Frederick. I have a little smaller one inside that came out of this unit, which I think actually might be defective. That's how I got this unit. But I want to be able to make my own controller. I got some parts to start building those and but I have to like not only make my own circuit board, put it together, you know, and I'm gonna use some schematic I found on the internet, but most of the people are designing them for like up to 60 volts when I need like 300 volts, 330 volts DC. So I'm gonna have to adapt them, and then get the microcontroller work, and then fine tune the software to start a compressor and stuff. I don't think that's gonna be an easy task. I think that's gonna be a learning curve and something over time. So it's kind of hard to rush that part. As I said, if I just had a small 3-phase compressor, I would just use a VFD and it'd be simple. But anyway, I've been getting pretty good at making those things. So I'm going to go in there after I get the temperature here. Holy hell. 204 degrees. 204 degrees going in. And let me put this up here out in the air a little bit, but see what it is coming out. I think the water's getting close to 120 in there. We'll go look. Give that a second to see what the leaving temperature is. I have that, and then I have a couple more loops. I really wish I would have probably, and this isn't even, it's taking most of the heat out. I can just keep my hand on there all day. You know you're not holding your hand on 200 degrees, not even for half a second. So this same compressor, like I said, in the previous winter, kicked ass. It only froze up a couple times when it was humid and cold, but other than that, it just kicked ass. And down in this thing, it just sucked. I never saw no 200. I couldn't hardly get the thing up to 150, and I had to come out here and manipulate it. I tried adjusting the charge, trying to do all these different things. It just wasn't efficient for heating. It kicked ass for cooling, but back to the 48 volts. 180, 300. Well, pretty much anything that's electronic that's DC is like 300 plus. So like this board here, this is out of a different kind of a carrier unit that I put in this group, and this is just a brushless DC fan motor controller, right? ECM motors all have it, but they have the controller built in. Some of these motors have these. It's a little tiny controller that's built in, but they all run on high voltage DC. So rectified from 208 to 208, you have about 300, and rectified from 230 volts, you have about 330. So what I'm doing is I have 115 coming in. I have my little voltage doubler circuit. 120 AC would come in, which was this, I believe. I got it unplugged. Well, I got to put this thing back in, and then it came out about 300 because of this voltage doubler between there and there, and that's how I was powering that up. Pretty cool. And now I kind of realized if I build big voltage doublers, I can actually power VFDs without a transformer now off of 115. Actually, now you guys seen the other videos, I've been running 480 volt variable frequency drives and 480 volt ECM motors off of 115 volt just by using a voltage tripler, just getting the DC bus within its acceptable range, and then it runs. It's actually pretty cool. The device doesn't know the difference, because it's all just DC inside. Most modern electronics don't have regular transformers, and they just immediately, like every wall plug charger you have for your cell phone, your laptop, everything, it just goes immediately rectified to DC to one large capacitor, and then it uses switch mode, buck boost and everything, buck and down actually usually, to make lower various DC levels to run all the electronics. But it's all just charged up high voltage capacitor to begin with. And the cool thing about it is, since they're electronic, is it doesn't matter if you put 115 volts here in America, or you can take that same power supply and go to Europe and plug it into that 250 volt or whatever it is they have. That whole range is acceptable, and because it is, you could stick DC voltage right into those two prongs that you would plug into the wall. It wouldn't know the difference, because it just would go through the diode and charge the capacitor. You wouldn't have to worry about, since it's full wave, you wouldn't have to worry about what polarity it was. It'll just automatically go through the diode and charge the capacitor of the right polarity. After that, the electronics doesn't know what you did. So realizing that's kind of funny what you could get away with. Make some of these circuits a lot more simple. So 107. So my 100, I guess my water heater is that hot. It must be pretty close to that then. But the water temperature is at the bottom of my tank is way cooler than the sensor says at top. So that's probably about right. So it's feeding 107, probably, a little under this. So it's cooling 200 degrees down to that when it leaves, which is pretty cool. But the thing is, this thing being compact and made like this, the very first thing I came up with, and it's capillary tube metering device I made, it just works perfect. Works perfect. Doesn't freeze up unless it runs forever when it's really cold, and it just works, man. It always recovers my water, and it seemed to do it in pretty close to the same time that my electric strip would do it. But that's 4.5 kilowatts, and this is 1,000 watts total with everything, the pump, everything. Maybe a little less, because I'm reading the thing in there. It's reading everything on in my room. So that's pretty cool. Turn this off. It is pretty warm out here, so I mean, this, you know, isn't the same performance it's going to have when it's you know, back down to 30 something in the morning or 30 degrees. But again, this is what I've had running for about 2 years, and it worked. I just want to add a defrost cycle to it. That's it. So it'll switch over to backup heat or something. So let's go inside. Just, I was gonna say, is it wasn't a total waste, because the last month plus I've been messing around machine, you know, making these circuit boards on my little for those that haven't seen it, this is my little machine, CNC machine I bought off Amazon that I have set up here, and I load the software right here, and I kind of, and just keep a bunch of these boards. I've been doing most of them as possible single-sided, and then just added a couple of jumpers on top if I have to, and then I could print a sticker out and lay, you know, the layout on my components like I did here, you know. So this is a 16F 887 processor. Try to get this thing back to 1:1. I don't know where that is on this. Pinch to zoom is really weird when you're live streaming. That's probably more like a natural shot. Oops, trying to make the comments disappear off the screen. Nope. There they go. So anyway, I've been getting a little better and better at etching these. I've learned some tricks, like my early boards were real, there were some things I would like to break would be the capacitor pads, and like where all these terminal header pins I put on, because these would be very small. Let's see if I can show you. Just these small, you know, pads, right? Where after a while, I learned in my software to fatten these pads up after the CAD software helps you lay them all out. I fattened everything up, make them oval or rectangle, and then make them fat, especially around the capacitors, right? I don't know if capacitors on that board, but anyway, you wiggle these a few times, it would break the pads right off the trace of the board. So my new ones aren't doing that. It's way more like I can safely plug things in as I'm experimenting, where when I was doing that on some of these, they were breaking. So this is the kind of trying to get this back right with the software. Like, this is just a simple thing. This is just my push button board I was going to make here. That was just going to plug with the header pin to this header pin and do a menu and up plus minus buttons for going through menus on the liquid crystal. And then you just it comes over to this, and I kind of move it to where I want it. And like I said, I'm taking these traces and making them fat, and I just do it in whichever direction keeps them from interfering with the traces. And then I do that usually first, and then have it add the traces. And I try to do everything on the bottom if I can. So now let's go to the more. So there's the main processor board right there. Down here is all my thermistor inputs. There's the processor, power, T-stat inputs, my LCD. Over there's for the going over to the stepper motor driver board right here. And then again, I did everything on the bottom except where it shows a top trace. It's really just where I just put a jumper. I just put a jumper there, and this worked out pretty good. Like, as you can see, I also fattened all these traces, fattened them up, even where the crystal is. Anything that could get rubbed and break that trace. Because I'm making this on the CNC, I found out that, especially where the capacitors are, I just fatten those up as much as possible, and then it works real good. So there's that. And then the code, I don't know how well this code's coming out. Zoomed in right here, but that's just the main loop. But I've showed this already, but you know. The other thing I was learning was learning to adapt from the PIC Basic Pro over to this C code, which is XC8 for microprocessor. There's all my, you know, and now I know how to do all this stuff in C. You know, there's switch statements, you know, instead of all if statements for different cases, you know, all my different functions, subroutines as they would call them in the other programs, you know, EXV switchover. I mean, I have all these functions, you know, that I got worked out, and it all works good. I'm gonna determine, you know, this is how I was determining modes. I came up with all this mode strategy, and then what it would do based on switching one mode to another and what to do. It actually worked out, man. This whole thing has worked fine in this little simulator right here. Let's see here. Check the comments real quick again before I go on. Get a telco HVAC system, glorified 5,000 BTU window units that cost 5,500. Whoa, lost. Where'd it go? There it goes. 5,500 are not inverter based. It cycles on and off every 5 minutes. Drives me. Ha! Is it not using an unloader or something? This is from Coltron. If I'm reading, I need to put my glasses on, contacts on. But I can't. There we go. Now I can. Now I see everything's clear. That's from Coltron. You would think, I mean, like a lot of people use like inverter compressors, but then some brands like Aeon, they still use a scroll with the third pipe port and the unload, and it just does it on a duty cycle based on like what, every 10 seconds or 15 seconds or whatever it is. But those things, you know, they actually control very well, and they don't have the inverter controls or nothing. They don't have the efficiency, you know, as an inverter, obviously, but they work. TXV and 134A, huh? Funny. They're trying to ban all those refrigerants right now, by the way, but so anyway, I forgot what I was saying, but let me hook this up. So I had this thing in test. I have a 24 volt power AC coming in, going through this just to kind of, I kind of add these to kind of, I notice on these little boards I'm buying, especially these ones, that they work, but when you use the upper limits of the voltage they take, which is 35 volts DC, so I'll rectify it from 24 volts AC, be right there. But I notice if you turn them on and off a couple times, sometimes they would just smoke, and it's the inrush current just hates them. So adding these little coils like chokes or reactors, whatever you want to call them, you know, kind of slows it down. This one here has the actual full wave rectifier, so it's made to put AC into if you want on this one. So this one seems to be less susceptible to that surge, but I still put that on there. And then this steps it for 12 to run the EXVs, and then I feed over here and this steps it down to 5. So if I kind of power it up, it says 5 volts. Those things I could buy these cheaper than I could build them. And I was just homing the EXVs, which I'm just using regular steppers here with just a thing. Oh, and then gotta turn this on right there. Yeah. So it's on standby mode. So right here, like if I want to put 24 volts to the air handler only, as it cycles through, it's, you know, it's reading the sensors, thermistors, and then, you know, it's going to see, AC only, and then the next part of the subroutine is going to be, what's it doing? Oh, it's going from off to AC, and it just opened that, and that's doing the countdown, you know, and it's going to turn on the compressor relay, which it just did, and that fan should be running too. It could be unhooked. I have stuff just kind of stuck in there. I could hear it want to run. I could have the pulse width too low. This stuff's been kind of kicked around, but I just had that to simulate a condenser fan motor, and it would go around and basically had all those controls working. See, outdoor speed doesn't need to speed up because it's happy. It's right around 83. So if I make the outdoor coil warmer, the next time it comes through, and after it reads the thermistor, it's going to see that 106. So that was basically the liquid line temperature I called out there, and it's going to start ramping up that. It's not see, there we go, speeding up the outdoor fan. TXV or EXV, it skipped a while. There goes the fan. I had the pulse width starting point just a little low for this thing to start, just using a transistor just to switch the negative side of it. Put that back into a neutral temperature there. But I had this all working. It would adjust the expansion valve. It would memorize it when you ended the operation. You'll shut down the compressor, and it would start with that position. The next time, it would switch over to the other one. If say I'm running AC only, right, and the water heater tank was below its high limit, it would go ahead and turn on the pump and go ahead and heat the water above the temperature that the water heater thermostat was set for, just up to a certain high limit. That way, hey, you're already using the energy to cool the room. The idea was to heat the water. There goes, water pumps on. So it would, while this thing was cooling, the idea was that one and only compressor would be dumping heat into that water heater to just turn that pump on until it got to a high fail-safe temperature, basically. 140, 150, whatever, it would stop the pump. So if I kick that back up over, I got it set for 140, so goes back up, it's going to switch modes after the next time it takes the temperature. There's a EXV superheat, and it will adjust if it needs to. So now you see that water heater's back up at 145, so it's going to switch modes. Mode 3, again, AC only. Now it's going to switch. The only thing it needs to do is cycle that pump for that. I have that all in the programming. If it switched, EXV or something, would be totally different. So I don't have another jumper out, but unplug that, let it do a shutdown. It was fun just making this stuff, but I'm just gonna probably take this controller and just simplify it to a one expansion valve controller and stick it out there and just let it run as an AC only unit. If I don't replace that unit with a cheapo mini split, which I'm very inclined to do because this is my experimental off-grid room. So basically everything in here is running off the sun out with my off-grid panels, not the one that I'm paying for from Solar City, but Tesla, but my homemade panels out back. Sometimes I bump these things and the readings off. It's been fun having all these wires like that. So I'm gonna go to what was on last time. HU, go to water heater, gets a call. Mode 1, water heater only. I'm gonna kick on that pump first. It would open the expansion valve, and then I always had this delay before it start the compressor. And it's gonna start it. There goes the compressor. Compressor's now running. Now, so it's using, it would be in water heater only, it'd be using the outdoor coil, so it'd be looking at the, I had all this I added a couple custom little text characters out here just to fuck around, see if I could do it. That's some sideways shit. Look, ID, OD, so it's evaporator, ID, OD, that's the inlet to the, so inlet for that one's ID, and the inlet to the evaporator outside was the OD one, and then they had a common suction line. So to do superheat, you're just looking at your coil inside or outside, and then your suction, and that'd be a superheat. So right there's probably about around 9 or so, and then it would adjust if it had, once it had to. Full speed. That thing should be on full speed, but something's goofy about this transistor setup I had over there. Let me, this is all hooked up good. And I just see I touched something and it stopped. Yeah, it's the way it's been. But this is just a pulse width modulator output, which looking on the scope, it's good. It's just that I kind of hooked this up in haste to run that motor. Uh-oh, I think my daughter's coming out here to disturb me out of the door. So I'll turn the suction temperature up, and it's going to see that the superheat's going to be too high now. See, 83 suction. It's going to be like, fuck that. I'm live streaming, child. So, I think we just missed it. Wasn't looking. Let's go back here. Once it goes past a initial timer when the compressor starts, it will start adjusting that expansion valve. So there it is. It's still on the counter to skip the corrections, because you need a compressor to run for a few minutes before the everything kind of balances out before you're going to start just changing the positions of the expansion valve. So I just have a starting point, which will be the last operating point, if it ran a cycle since the power was reset. So here in a second, all right, now it's opening. See, now it's going to start calibrating. So it's just opened from 35 to 36, the position. And then it reached, and I just have it going through all these different things. And most of this is just for me to troubleshoot and look. I don't even have to have this, but I think it's cool. So now it opened from 36 to 37, and it's going to keep doing that until it got no more than 12 degrees superheat. And if it went below 10 degrees superheat, it would start closing the valve. So I could kind of I just have these simulating my thermistors. And I kind of just jack with them to see how it works. Now we got back to 60 and 50, so it's going to be pretty happy. It shouldn't do any adjustments then. Oh, I had it down at 9, so it just closed it. This is a real fine touch to those little, oh yeah, 51 and 60. So a little fine touch. So I have it, all that worked though. I mean, it's the same kind of strategy I'm using on the other circuit I built, and it worked. It worked all summer long. It refrigerated just fine. Actually, could have used it. Actually didn't run long enough because it was too much. Even though it was like a little under 1-ton compressor. So this room also, as I knew it would, I didn't need heat. Like, this is not heat. And because as long as I close this bifold door, because the garage would get freaking cold when we got down, in the 30s in the morning, and it'd be like 50 something when I came home. But as long as I close this thing running, the refrigerator, and just what losses the insulation from the water heater, it would keep it over 70 in here as long as I kept this door shut. And I just regulate it by cracking it open if it was a little too warm. Like on a day like this, I'll have to keep this door cracked because see, it's 77 freaking degrees in here. There ain't no heater in here, so it's actually plenty warm. It's a little warmer there than it is right here, but the TV and stuff. But pretty cool. But anyway, this has just been basically the art of tinkering, And I tinkered. So stop that, and it'll go back. And you can see I was using the outdoor expansion valve because it was just heating water. Oh, I forgot to flip the switch over here so you could see what it would do, a mode switch. It's pretty cool. I know I already showed most of this stuff here. I'll turn it back on, water heater. Wait for it to start up again and show you. Check the message. So guys, Coltron still telling me about Telco HVAC. I have to look into that. Never heard of it. Is neglected, and they charge way too much for them. They seem solid, but still, for the price and what you get, it makes me mad. I'd want to scale it with the load. Yeah, it's pretty crazy to look and see what he's talking about. Glorified 5,000 BTU window units and cost 5,500. So these are like cooling like small electrical rooms or something, like where they don't need much but they do need something. Is that what those telcos are? By the name of them, that's what it makes me think, telco, like for like a telco room. And maybe they are just a real robust, simple, low maintenance, don't break down very often type of unit, don't have all the fault codes and stuff to make, and also maybe there's something that people are able to get working with what's on their truck when they get there and they drive. Maybe they're, like a little tiny server room up by a cell phone tower out in the middle of nowhere where you usually would see like a bar unit or something, but maybe it's just a small one that doesn't need much, but it needs something. Maybe it makes sense because you're one of those guys on a truck and you go out to go fix those things and it's got all inverter boards and stuff and you got a fault and it's going to be something you order parts and you ain't fixing it with what's on your truck. You ain't putting a contactor and you ain't rigging anything. You ain't working around that inverter board to get that thing running. This is the only bad thing about all the electronic motors and stuff and the new axial fans and stuff. You can't just throw something else in and get it to work. So okay, so it's running. It's just doing, and then say so it was calling for heating water only, but then I'd have a thermistor in here, and where is it? My space temperature got warm. That's where this thing the hybrid part would come into play, is it would see that space. They get it warm enough. Yeah, I think 79 is above this. I think 72. Yeah, mode switch water heater only to basically hybrid. So it just switched off the outdoor expansion valve and just went to the indoor one while the compressor's still running. I was gonna try that. I think it would work. It would probably, and it would just have to wait to reinitiate the skip counter. Yeah, countdown. See, I just had it at 10 for right now. Now it's down to 9. Where I'm like, it's like saying I'm not gonna adjust the expansion valve. Let it run. Let it run and balance out, get the temperature stable. Then we'll start looking at those temperatures and making adjustments. Now it's countdown 8. So, and I could have changed that. And I was going to add all those modes so I could just go out there and push these button boards to change all those buttons to fine tune it. Which is what I did with the other one, but just didn't. Pretty cool. But so basically, just to break it down, this is just a optical isolator board. So you're at your 24 volts AC, or I could stick DC into it I wanted to, whatever. It just turns on an optical isolator. You got your current limiting resistor and a diode just for the, basically think of it as an LED in there. And then on the out, this is just an isolated, 5-volt logic. Oh, I just touched something. So, pissed something off. Anyway, yeah, so 5-volt logic, just tell the processor what it was doing. And then it just had all the outputs, thermistors, LCD, going over here, output to my stepper motors, and then the relay output, for the relay board. Just think of that as being binary output, analog input, binary output, stuff like that. Binary inputs from the 5 volts switching. Pretty cool. So turn that shit off. And then see, I turn off the power. Every time I first power it up, I just have it hard home the expansion valve, so they just close. And they only make that noise just when they hit the home point. They're quiet otherwise. But every mini split, VRF, VRP, all that stuff all does the same thing. You first power it up, put your hand on those expansion valve domes, and you're going to hear it. Once it spins all the way and can't turn no more, and it starts skipping, the magnetic field goes around, it's going to bounce, and it's going to go click, 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 and that's how you know they're homing and that they're actually turning. So anyway, everybody's probably off on break today, probably can't get that many people, but I just figured I'd do this just to kind of as an update for project and stuff. And I don't know, I built a really cool thing. I don't think I didn't make the video and upload it yet, but I made I've been experimenting with all these voltage doublers. Like, here's a voltage doubler. I'm able to plug this in and run that fan, run a 230 volt VFD, all that kind of stuff. And then I was messing around with like voltage triplers and stuff. And here's a little bigger one. Well, I made it even a little bit, one kind of like this, but a little beefier. And I put it in a nice project box to take to work for testing VFDs and ECM motors and stuff. It was pretty cool with just plugging it in, sitting, at 115 volt in, just to test them and stuff. That box came out really nice, so I might make a video of it. This thing's all muddy. I had this thing in this Can-Am, and so evidently, I thought the battery was totally dead. It actually is reading voltage down there. Maybe it's just the amp part that's dead. These take 2 of the 2032 batteries inside. It's kind of funny. These are 2 independent circuits in here. Like, this circuit down here runs off one battery, and then the amps, which can run at the same time, they were on their own battery. They weren't even like on the same, power supply. It's kind of interesting. These things were based on the exact shape of what they made back in the 60s. I actually had one of those analog amp probes, but I don't know where it went now. Too much. These are just experiments, stuff like that. This was a 460 volt motor, and out of one of those carrier axle fans I've been messing with, and with my voltage tripler I'm able to run that thing. So I think I might have already done a video on it. There's a compressor that came out of that mini splitter that we're looking at out there, seeing it's DC. Somewhere it says it. Oh, my glasses down. Let me see what it says. Yeah, right there. 160 volt DC, 120 hertz. The other one out there says 180. Kind of weird. Anyway, we're getting up towards. See, since it's been running, this thing was in the teens. I started doing the video, and look, it's up at 122. The water is really almost too hot to hold on to. It does come out of down there. So I do notice that once this thing kicks on sometimes, this temperature drops. And actually the temperature of the probe drops, but I realize what's going on is like, you're taking hot water off on the top, and then your cold water coming in goes down to the bottom through the dip tube. And it's also, we kind of got it swishing a little bit to try to keep the sediments at bay. But because my pump was drawing off of there and putting it right here in the sensors here, once it hits the point of kicking on, the temperature drops quick. I was like, man, someone's really running or even using a lot of water. But what it is it's mixing it up, and it drops the temperature, like averages it all out since it's circulating. But then it'll run until this point gets up to 135, nice and warm, and then it kicks off. So it works. But the cool thing about not using your electric elements is you don't get all electrolysis effect, I think they call it, where the scale all like forms into a rock down on the bottom. So using a heat exchanger and the water moving with a pump, you're not going to build up all that stuff. At least it'll be really slow. So the tank lasts a lot longer. And I replaced this in 2019, and it's hardly, most of its life's been heated with a heat pump. Yeah, pretty cool. Anyway, all right. I just wanted to make that update. I guess I've been streaming a while. It's not all that many people watching, or they're probably all pretty busy. And the live stream doesn't quite record this stuff as clear, I guess, as it would be if I recorded with something else or screen captured. But just it was if I open up all these compressed lines of code. There's like 136 lines of code just in this function determine mode. I mean, it's a pretty long program. I filled up 95% of the memory that I wrote in there. So it was pretty maxed out. And I would free up a bunch if I took out all this stuff for my own little debugging, my LCD subroutines and stuff. If I actually needed more functions to work. But this is cool, and I just it's cool to look at the LCD to see what it's doing, and just to do it yourself. And I'm trying not to let this room get too destroyed. I mean, it looks like we're somebody fucking Frankenstein's tinkers, but it's not horrible. But I do need to keep up on it. I probably need to put up a couple more shelves and maybe store some papers. I try to keep a lot of these, on the clipboard here. They're in color. That's my processor right there. And then these are all the port nets. They basically just keep it clean. It's like these are my 6 thermistors. Compressor output going to the relay board. Pulse modulation output going to the fan board. Out to the dual stepper motor driver, power plugs, programmer plug, crystal, stat binary inputs from the stat from its little converter board, and the LCD thing. I don't know. I like the software. It's pretty cool how you can just print that out. I can just kind of if I'm working on it, just tag it up over here and look at it later. Or there's my dual stepper motor board, and I could just keep building the same thing and making it for other projects, or just take one off and use one, whatever. And just once I save some of the stuff, I could just slap a board up on there and make it. And one cool thing I've been doing to make these boards faster and not have to flip them, because at first, when you use a double-sided, you have to make sure you got your alignment holes, everything right when you and didn't make one mistake, because you'd flip that board over after you did all the work of it etching the one side, and you flip it over to etch the top side. If you didn't have something lined up, either that top CNC trace wouldn't match up with the bottom, or when you went to drill, that would be off, and you would just be, damn it, you have to start all over. But I've been able to figure out how to just do everything on the bottom, and just maybe if I have to, I'll add a couple jumpers. Like there's a jumper, there's a jumper. There's just a couple, and there's like 6 or something on this one. It just keeps everything there, and then I figured out I could start printing out stickers and putting them on first, get them lined up, and then it shows where all my components go and everything. I think that's pretty cool. So getting a little better at making those boards, just cheap, boards off Amazon boards, I buy, little, like I said, tweaks to make the pads fat so they don't break. And now I'm making pretty cool little boards. It's a real simple one. It's just a push button board, but anyway, it's coming out pretty good. I had one more comment to check out, so. Post-stop. Trying to remember what your video was now. Somebody told me to look at a video when I looked at it a couple of days ago. Someone else chimed in just when I'm getting ready to end the stream. Happy holidays, Dr. Frank. Happy holidays back to all you guys, too. So, today is the day after Christmas, and I had to come out here to make this real quick. Getting a mini split unit in. Cool. So the guys that just came in, if you want to see me ramble and just what I'm doing and what I'm not doing, because I'm going to changing my paths. That's the way I am, man. I'm indecisive, or just tinker, or just suddenly I change my mind. You're going to have to watch the playback of the video later, but hopefully all this came out clear enough. So, and there's my little tapper. I've been to make some of this kind of cool. I've just drilling a hole with the one drill bit and then tapping it. And then I was able to screw all this stuff right to this plexiglass. It actually made it pretty cool to mount all this on there. So, Homemade chiller. That's right. I forget. I commented on your video there post-op. Oh, my daughter's coming back out, so I probably do need to get going. They're waiting on me. But something about it, I can't remember what I said. But go check my comment, and then if you reply, I'll probably get the notification. So, what do you want, child? You waiting for me to get done? Huh? Oh, you getting into dad? Whoa, you getting into daddy's fridge that you're not supposed to be getting into? What are you doing? This is my stash.
Where's my fan?
What are you looking for?
This is mine.
You better go get a warm one and put it back in there.
Get it.
All right. All right. It's been almost an hour now, so.
These are my fans.
Okay. So anyway, I'll let you guys go, man. Just showing what's going on, and then later on you'll see that thing probably repurposed into something else out there, and then basically the first Frankenstein or second Frankenstein heat pump, the little one that's out on the wall with the rotor compressor. I put it back the way I've had it. That actually worked. It's just the hybrid doing two things with one compressor just wasn't going to work. It would if I would have had a larger compressor. It could speed up for heating the water when it was cold and slow down when I needed to cool the room and things like that. But that just didn't come to be. So anyway, kids started to drive me nuts.
All right.
I'll catch you guys later, man.
To like and subscribe.
Yeah, she says don't forget to like and subscribe and all that stuff. With that, I'll catch you guys later, man.
And comment
Peace.
if you have any questions, and make sure you share too.
Share. Yep. Catch you guys later.